What's up, everybody? Spare Wood a Gun here from Sleepless Nights with another episode on Space Engineers Programming 101. When we left off in the last episode, we finally got our solar code working to where you can retract the solar array, to which it stops, and then you can activate it to extend it, but it will stop itself if it reaches a point where it's losing power from where it sees. Plunk. Now, there's a couple other things we need to work on. One is the Y factor of its spinning is still not happening. This state spin function doesn't seem to want to, well, function. The other thing that I want to do is implement some kind of override system. Probably going to be... I'd like to make it some kind of button or something, but I'm almost thinking internally, toggling it through code. To where if it's set to override, then it won't stop until the piston is fully extended and the rotor is fully locked, kind of thing. So let's put in... Screw it, let's just put it down here. And we'll put in a Boolean value of full extend equals false for now. I have not looked at the code here in a bit, so it'll take me a second just to get my bearings on where everything is set up. Piston extend. Where was the point? So, optimize power panels, or optimize power is what basically ends up turning everything off. Okay, so if this blah blah blah, let's put a case in extend, maybe? And we'll say, if full extend, or if not, that'll be easier. So if not full extend, then basically we want it to do all of this. Otherwise, we want it to move on and act like nothing's happening. This, in theory, should give us a means to let the piston and the rotor actually fully extend, even if it reaches a point where it's losing some energy. And we'll go ahead and set this to true to test this out for now. Alright, so now let's try it. I'm going to extend it. So theoretically it shouldn't stop when it hits that one point. And it looks like it is not, which is great. Okay. Now, there is one factor that we have to take into account, and that is, do we want it to actually change this value once it's reached a certain point? For example, the rotor is probably the most important part because the piston is just straight up. But, I mean, we could leave it there. We could leave it there, probably. Because, what is it? Does piston extend call anything else? Forget distance. Set value to... Okay, so it turns itself off at a certain point, but the state doesn't change. Now... Okay, so now we do have a problem with this in here. If not... Let's... Oh, I know what we can do. We can check and say... And... how do we access that value? Let's try... piston.velocity is not equal to 0f. The reason I'm putting this in here is if we're in the piston extend state, but it's done extending, then theoretically we've reached this point in the code which sets the value of velocity to 0. So we could actually test this a couple ways. We could test for the piston velocity, or we could also test to see if it's actually on. That would be the other thing. So this is going to check to see if full extend is true, but that this is also not equal to false. Now what I want to do is put in a... Or wait a minute, no. No. I want to make sure this is equal to false. My bad. Or equal to 0. Right? Because if full extend is true, or is not true... Oh, I see. I see what I did there. Okay, let's not do that. So we'll say if it's true, which is an else. Or let's try an else if actually, and do if full extend is equal to true. And now we can test for velocity, I think. Equals... Yeah, if it's equal to... Oops. If it's equal to 0, and it's true, we still kind of want to do this anyway. Oops. Oops. Dang it. What am I doing here? No undo? Okay. Now, actually, hold on. There is another way we can try and do this that I think will work, and it'll save us some time. We're going to do an OR. So 2 lines make an OR. So it's going to check for this first. So if this is not... if this is true, meaning that full extend is false, it will just run. Otherwise, it will check the second condition. Sorry, that's hard to explain. And I'm going to put it in parentheses and say if full extend is true and piston velocity equals 0f. And then close that. What this should do is say if full extend is false, we're just going to go ahead and run this. If it's or we check to see if it's true and the piston velocity has no value. If that's the case, then we want to set full extend to false and see if that works. And then I am going to put... No, I'm not going to actually. I was going to put the setting it to true and start up, but that would just erase it every loop, so that's not going to work. Okay. So now that should be set up. Now the interesting part is I don't know why it won't spin, because I was pretty sure there was a spot that set that up. Oh yeah, here it is. So we have if extend light is working, then extend. Else if retract light is working, retract. Else if state equals piston extend, then it should call the spin function. And if it calls the spin function, let's just step through this code real quick. So if it calls the spin function, it should do this, which sets the state. Then it sets the rotor Y velocity to 1. And then it applies the action to turn it on. Then it will run optimize power. So under those conditions, it will get the current power. It will compare like it always does, blah, blah. So the switch state should have it in spin. I feel like a laundromat. It should have it in the spin cycle. Okay. So if this case is true, then it should be set to spin. So rotor set value should turn off, state equals optimize, and then break. And then optimize will go through and do all that. So the interesting part to all this is it should be calling this right here. Yet, the intriguing part is that it... Oh, okay. So the intriguing part is when it gets to like this, now it's set to spin, but we are seeing a severe lack of spinning. Like it's just not rotating at all. Which is very interesting. Wait a minute, Could it be that simple? Hold on. Oh, no, it's fine. So the only thing I can think of... Well, no, we can control the piston. I was thinking the only thing I can think of is that it's connected to a rotor and a piston and stuff, so it might not be, like, as accessible, but... Okay, hold on. This is set to off. That seems suspicious. Alright, let's check our code. See if there's any point... I know I started things off by turning things off. So we set it to off, right? But this happens every frame. We did that with the main rotor on the rotor X value, and it seems fine. We did it with the piston, too, and it seems fine. So we set the braking torque. We didn't set an upper-lower limit, but it shouldn't matter. We do all this. So from here we go to the spin cycle. Set state, set velocity, apply action on off. So it should be turned on by the end of this state. The only thing I'm wondering is if I have to... No, I set the X value's velocity before I turned it on, so that should work. So we're in the spin state. We run through this. Now we get to optimize power. And other than the case state, which turns it back off, or sets it to optimize, so the state should still be set to optimize. Yeah, I don't get why it won't spin. The only thing we could try, real quick, is to up the velocity, and in that way see if it's just a rotation thing that's causing it not to go anywhere. So let's try like 5. I mean, it's kind of extreme, but... Yeah, it's just not spinning like at all. Whoa! What just happened? What was that? This thing's freaking out over here. What did I do? I think I might have adjusted the wrong value. That I might have just adjusted the X value. Or the Y is trying to spin and it can't. One of the two. So what did I change? Where's the velocity limit? Or value? There's the piston. Yep, I totally set this value. Oh, gosh. This is why we can't have nice things. Alright. So it's retracted now. Let's turn that on. Okay, so we'll watch from here. So we're in the extend mode, as we always are. The power, you know, it's gonna backtrack. Or, I mean, we've got it set to override, which is fine. Piston extend mode. Now it should get to spin, and then... Oh, it went straight to stop. Alright. Well, that's new. What is the stop function? Okay, stop happens at the end of optimize. Huh. Well, now, isn't this intriguing? If last power is greater than current power... I see what I did here, okay. Or wait, no, this is supposed to only trigger if it reach... Oh, but it's triggering anyway, we're overriding it. Ah! Oh, I'm a dum-dum. I know what we can do here. We should probably put it as... We should probably take that line that I highlighted out and put it up in the else-if clause. That might help. Maybe. I'm not sure, like up here. Because we could put it as... If this... and full extend isn't true. Because what I'm thinking is, I'm wondering if that would keep it from... Because what's happening is this is going to get called anyway because of this. Because we're making it move past the last power and the current power, the current now, because we're overriding it, will always be less than last power, so it's always triggering this. Then when it gets down here, we've already set this to true, so then this isn't triggering, but then this triggers, and once the piston's fully extended, the velocity is no longer 0, this runs, triggers it, sets to optimize, which then skips the spin cycle altogether, because then the next time optimize power runs, it triggers this, which triggers this case, and turns everything off, and sets it to stop. So the problem here is how we've got the logic set up that if we want to override what we're doing to where it will always like fully extend, then we have a bit of a problem. Now, there is a simple solution to this, and it's something that we might adapt instead of trying to do this, because this is kind of going to cause a problem, which we just saw, like, just bear witness to the problem itself. So what I'm going to do is remove all of that, so that it's no longer checking those conditions. And what we're actually gonna do is test the code. I won't actually keep it. Well, no, I am gonna keep it, but I'm not going to keep the setup this way. Full extend does not exist. Where did I leave it? Ah, here we go. Anyways, what I started to say was, instead of running it through code, let's retract this. We're going to, for testing purposes, try this out a different way, and that is to make a barrier that will keep it from getting a good source of light until it's actually fully developed, or extended. So this is more of a testing solution to prevent it from breaking, but it's not exactly a how do I put this? It's hard to explain, but what I'm going for is the fact that it's not exactly something you would do in code. It's mostly just to test it to make sure it's working. Like, if you positioned a ship to the point where like, okay, so from here it's getting more power, right? So what we want to make sure that happens is that it will get more power if it moves again. Of course, we'll have to actually, like, change this up, but let's move this out a bit more. Because this is kind of in the way. It's going to run into the solar panel. And we'll bring this out as well. I need the shadow to hit right about where it is. So that when it fully extends, it'll actually do more. So I'm hoping this is kind of making sense, but instead of actually coding in an override, what I'm trying to do is manually override it by not allowing it to see the sunlight until it reaches a point where the piston's going to extend past what it needs to see it. I hope that makes sense. And now I'm not even sure it will work, to be honest. Let's bring it back down. We'll try this again. Because in doing it this way, we get the same result of testing it without actually having to put code in to keep it from moving the way that it's supposed to move. So this way we can make sure the functionality is there, but in reality, if you were actually running this on your ship, then when you extended it, if on its way up it achieved max power, then it would just go ahead and stay there. So let's trim this down by like 1. Maybe. So I'm still confused why this spin cycle won't actually go. Oh, because it's in stop mode. Of course it is. Let's try and just switch it. Oops. What's happening here? I really have to go all the way back down. I have to fix something in the retract code or something at some point, because it's acting like I can't get it to re-extend because it keeps power cycling it back into stop. Which I thought I had worked out, but I guess I don't. Oops. Come on now. Don't be like that. There we go. It keeps stopping. Dang it! Darn you, son. Alright, so... that's annoying. How do we... there's gotta be a way to fix this, because I'm trying to get it to go up to the point where we can check the spin part of it. Without it actually needing to have a manual override code in place, because the override's going to cause problems. So I tell you what, let me derp around with the code a little bit here, see what I can come up with, and I will be back in a minute. Okay, so quick update. I have not actually gotten the full spin cycle to work, I don't believe, yet. There is something in the code that keeps turning... I know where the problem is now, though. The rotor keeps turning off. For some reason. I'm not really sure why. Because based on the code, there's only a few spots where turning it off is even called. So, like right now, it's in the spin function. We can see that. And it's set that it's not spinning. But it's not changing state, it's just not spinning. I did add a few things. One is this right in here. I noticed that I had it set to if state equals piston extend to call spin. I never had it set to continue to call it every time if it was set to spin. So now it should be set to make this spin. And I'm going to add this back in. I wasn't sure if the braking torque was causing a problem, but it's not. So yeah, we turn it off up here, which is normal, but again, when you get back here, if the state is in the spin cycle, sounds like a dryer, it should run spin, which automatically turns it back on. So I'm a little bit perplexed as to why it's not actually going anywhere. It could be an order of operations thing. I'm not truly aware of what's going on. So I've been cycling through some of the different stuff. I also found an issue with piston retract. Here it is. In this was the original line, which in hindsight makes no sense, and I don't need this anymore. Because that didn't work either. It's basically saying that if the angle is not 0 or it's not 360 degrees, then turn everything off. So it's basically taking into account if the rotor had spun somewhere to pretty much turn it off when the piston's coming back down, but I had this backwards to where it wasn't actually going to be turned properly. I wanted it to correct back to its original position before it retracted. And I had this set to where it wasn't 0 or it wasn't 360, which is the direction I need it to face, then turn everything off and retract the piston. So I cut this line out and changed it to where if it's equal to 0 or equal to 360, aka the default position, then turn the rotor off, change the velocity. Actually, I should probably do this first, just so the braking torque takes effect. I don't know if that really matters or not. It doesn't seem to, but I'm going to move it anyway. Okay, so then I added a clause down here that says if it's not equal to 0 or not equal to 360, then we set the value to 1 and turn the rotor back on in the off chance that it actually is off. So this actually works, but the spin cycle is still not working for some reason. So we're setting the value of velocity, which should be correct. It's been working. Like up here it works. Set value. Let's just copy this and just make sure that it's not something in how we have this typed. It shouldn't be, other than the fact that it's a 1. But yeah, I don't quite understand exactly what's happening here. Why is this commented? Oh wait, no, I was testing this. So now that it's commented out... Alright, so it's set to the start function. And I also changed this button to trigger the timer block as well. So let's turn this on. It went to spin. Ah! We got it spinning! Awesome. Okay, now, assume we're done, right? We don't need it to do stuff. I want this to retract. Now watch what'll happen. Because this was actually kind of impressive to me. I was glad we got this to work. So it'll spin, spin, spin. Now we'll have to actually make sure that the optimizing code is in place. We may have to move the state for spin out of that original code. Just because I'm not sure if it will cause it to optimize if it's stuck like that. So now watch what should happen when it gets here. It should stop itself and then start to retract. So, clunk, and then it retracts. Perfect. So it will basically bring it back to its default position before bringing the piston back down and retracting the rotor, which is perfect. So I have code in here. I did put the extension override back in. I don't know if it actually works right. So in optimize, I have it set up to where if extend override is false and last power, current power, or last power is greater than current power, or the state equals optimize, then this gets called. The problem here is, like I said, this is going to override this, but it's also going to override spin. So what I'm going to do is we'll actually copy this. We'll actually copy this. And let's make a... And if state equals piston extend and piston.velocity equals 0, then extend override equals false is what I should say. Because if the state equals piston extend and the velocity of the piston is 0, it means it's reached its max distance. So it's done. The only problem with this, where is the piston extend function, is if it starts off with a 0 velocity, it'll default to that anyway. Nope, it starts with extend, rotor, piston extend. Okay, piston extend, state changes and the velocity gets set. Okay, so the state is only 0 and piston extend if it's hit its max distance. We could also do this too. We could also call this here. That might actually be... no, we'll use velocity because that makes also makes sure that it's off. Yeah, we'll do that. So that's fine. I do feel like we need to change this to false though, because extend override gets it past the extension, not the other way around. And it should never reach optimize because the state is only changed to optimize within this clause here. So that should be fine. So with that in mind, what I'm going to do is I'm going to get rid of all this and then we're going to test this out. Alright, so, moment of truth. Oh, and there's one other thing we could add to this real quick, and that is in this area. Let's copy this. We can set this to true for now. Or wait. Let's copy this whole thing. I'm gonna copy this just because of the way the editor works. I want to make sure that I got the full line, and then we'll get rid of that. So what I'm gonna do here is comment this one out, and then I'm gonna change this to true so that it appends, and that way we can add things to it. And why? Oh, okay. And then at the end of this, this should be following. Okay, we don't actually have to do that. Now that I think about it. Wait. Where did all this go? I think I hit undo too many times. Let's just close that out. Alright, so what I wanted to add to this was here. This is state. Let's add extend override. There we go. So this will tell us what the extension override is doing as well. So now we can hit extend. So it's set to true. Now we'll see if this actually... Alright, so it keeps moving. Good, so the extension works. Now it should get all the way through to the piston extension. And then when it gets up to fully extended, it hits false, but it changes to stop. Okay, that's not optimal. So the only time it changes to stop is after it's run the optimized code. And it should only be running optimize if this is false, last power is greater than current power, or the state is optimized, but it won't have gotten to that point without it running through there. Oh, I see the problem. I see the problem. So last power is greater than current power because it never updated past the point where it hit the most powerful thing. So we need to update that if there's an override in place. So this gets updated here. This is the current power. If current power equals optimum power and state is not equal, if last power is equal to 0, so that's initialization. Okay, if current power is greater than last power and state does not equal optimized, then we update. What I also want to put in here... Oh, wait, no. It's got a trigger from there. Okay, then what I need to do... I'm not sure if I should actually have these all in as else. If last power is equal to 0... And I apologize, I had it set to record my mouse. It doesn't seem to be doing that, though, in the last few episodes, or any of them, so I'm trying to highlight when I'm pointing at things so you know what I'm thinking of, but... I'm wondering if this and this really need to be an else, or if they should all just be ifs. Well, this... Basically, it comes down to if it's going to contradict it. If last power is equal to 0, which means it's never been instantiated, and current power is not equal to 0, then update them. That doesn't need to be an else, so we'll just put this as if current power is greater than last power, and state's not equal to optimize. What I will put in here is... also, and I'm going to take this out as an else as well. We'll just make that run anyway. So let's just, in keeping with that... Oh wait, no, this could be an else. So let's do else if extend override is true. If extend override is true, we're not trying to find out what the power is yet. We want to wait till that's no longer an option. So it would make sense to just make it update anyway. So we're going to try this out. And see if this works. Okay, so it's in a start. Let's retract it. Piston retract. Let's turn this off. It should stop. We'll extend it. So it's in piston extend mode. It's equal to true. Spin false. Yes, it's spinning! And it's updating. And it stopped! Awesome! We did it! We did it! We did it! We did it! Alright. So let's run this through to completion here. So when we hit retract, it's going to basically override any optimization code just to bring the thing back in. Now, we could do this really picky as far as you could do... Actually, you know what? I'm going to do it. I am going to do it. I'm on a high right now. So what I'm going to do here is in the... Where is it? Piston retract mode? Okay. So I have it set here to where if either of these is true, right? So what I'm going to do is put this in another if clause and say if get angle rotor y, let's see, 180 degrees is the middle point between 0 and 360. So we'll say if rotor angle is less than 180, then what I want to do is have rotor y set value velocity single and then put a -1, so we're going to make it a negative. We can actually just copy this. So in case you're not familiar with what exactly is going on here, we're always in the piston extend or piston retract function. If it's equal to 0 or it's equal to 360, it's going to set the velocity to 0 and turn itself off anyway. So what I'm doing here is I'm testing the angle to see what angle it's at. Let's do greater than or no. Yeah, we'll do greater than or equal to. So if it's greater than or equal to, you have to take into account if it actually equals 180 somewhere in this, or else you're going to get stuck. And then we'll just bring this code up. So, in theory, what this should do... let me save that out. So what this should do is state that if the rotor is not equal to 0 or 360, aka the default position, then if the angle is less than 180, spin it backwards with a negative velocity. So you have less time that it's spinning, essentially. And then turn it on, and then it will do its thing. Otherwise, if the angle is greater than or right at 180, then we're going to set the velocity to +1 and make it go the other way. So, for example, the current angle is 149. So what I'm trying to accomplish here is it's less time to make it spin back this way than it would be for it to spin positively. So, in that regard, when I hit retract, it should spin the other way. Yes! Awesome! 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 It's awesome. It's true. So that will save time that if, okay, for example, let's stop it right there. And if we were to make it go, Alright, so right now it's optimum, so pretty much. It is less, it is slightly less. That's the only thing. I would really have to refine the time cycles, the ticks and stuff. I would really have to refine to get it to be perfectly optimum, to where it never... It's like it's always going to equal 145, you know, whatever the max power that it can find is, instead of being slightly less. Like right now we're a little bit lower than optimum, but I mean it's really close. But the angle is such that it shouldn't spin all the way around to come back. So that's what that last piece was about, was now when we hit retract, it'll just spin back. And then it'll stop. And then it'll stop, theoretically. Anyway. Blunk. And then it comes back. Gosh, this is awesome. It's actually working for once in my life. Alright. So from start to finish, there's a value in here called extend override, which we can adjust. Now, you could make this user input. You could actually have this as a third light that says override. And you know what? Let's go ahead and do that. Why not? I like to make things easy for people. So we'll set this to interior light. We'll set this to solar extend override. And let's do like yellow. That seems like an industrial way to do things. Okay, and I'm going to copy this. Programmable block, edit this. We'll start off with it equal to... No, actually, okay, I'm not going to do all this, because then we'd have to go into turning the light off and blah, 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 blah. So I'm just going to leave it as a line in the code that you can change if you want. So for now, we're going to set it to false. And remember it. So we'll hit this. It'll extend. When it reaches its max point or optimal point of 22 or 22,000, so that's almost full power right there. Then it will stop, which is cool. And now we can hit retract, bring it back. All right. And now if we were to set this to true, which means even if it's not always the most optimum, I want to make sure that the piston comes all the way out before spinning. Like it goes fully erect at a 90-degree angle, or a 45-degree angle. I always get it mixed up. I think that's 90, because 180 would be this. Yeah, so it's a 90-degree angle, right? I don't remember. I'm bad at geometry. So then it will go up, and then it will spin to find what's optimum after the piston has extended. Which is right there. Awesome. It actually works. Exactly how I wanted it to. So, yeah. This basically gives us two modes, depending on how you want it set. It's more about based on your build design. If you have a flat hangar door that opens and you don't care about it extending all the way up, then you can just have it be optimum. Like, you know, wherever it's optimum, just go ahead and adjust. Now, the one thing that we don't have is for it to constantly be adjusting. At the moment, it goes to a stop function to where if we were to be on a ship that then moved, it wouldn't constantly be moving around to make sure that it's always getting the optimum light source. That's something else. Let me know if you guys want to see that. If not, I'm calling this script complete, because it's basically like a pack it up and deploy system where when you need power and you're going to be sitting still, boom, deploy it. When you're going to move or something, pull them back. Like your batteries are charged, pull them back in. If we wanted to set it up to where if the lighting moved, then it tries to readjust, that would be a whole nother ball game. It would be another set of code that we need to add. So, let me know what you guys think in the comments. In the meantime, I hope you all enjoyed. If you did, leave a like, and I will see you all next time. Peace.